Hello and welcome to my quick quiz on histograms. There are 10 questions. You need a pen, a piece of paper and a calculator would be useful. So let's get started. Question 1. Question 2. Question 3. Question 4. Question 5. Question 6. Question 7. Question 8. Question 9. Question 10. That's the end of the questions. Let's move on to the answers. Question 1. For the class of times between 4 and 6 seconds, we're given a frequency of 16. We know that the frequency density is the frequency divided by the class width, so the frequency density is 16 divided by 2, which is 8. Distributing the frequency densities evenly, then multiplying by the class widths, we get 12, 24, 12 and 16. Question 2. We need to draw extra columns, first for each class width, which are 15, 10, 10, 5 and 30. We can use the formula to find the frequency density for each. Dividing the frequency by the class width, we get 0.8, 6.6, 9, 9 and 2. We can draw the histogram with the vertical axis between 0 and 9 and the horizontal axis between 0 and 70. Remember, there are no gaps between the bars of a histogram. Question 3. The easiest way to group this into a frequency chart is to first use a tally. For each number in the list, we need to mark it in the tally chart. When they're all added and put into the frequency column, we can then work out the frequency density for each using the formula. The histogram shows the frequency density on the vertical axis. It needs to show 0 to 0.8, and the horizontal axis is for the marks, so needs to be from 0 to 100. Question 4. We start by calculating the number of eggs in each class using the formula. Frequency density multiplied by the class width, getting 4 that are between 62 and 63 grams. Then 8, 14, 24, 20, 16 and 8. To calculate an estimate for the number of eggs less than 66 grams, we just need to draw a line at 66 grams and total the frequencies before that, getting 50 eggs. To find an estimate of the number of eggs over 68 grams, we draw a line at 68 grams, but this is right in the middle of the bar. As the bar represents 16 eggs, half of it represents 8 eggs. Added to the 8 eggs in the last bar, this gives us an estimate of 16 eggs that are above 68 grams. Question 5. Using the formula, we can work out how many children in each time period completed the puzzle. 0.8 times 5 is 4, so 4 children completed the puzzle in under 5 minutes. 4 completed the puzzle between 5 and 15 minutes, 6 completed the puzzle between 15 and 25 minutes, 7 completed the puzzle between 25 and 30 minutes, and 4 completed the puzzle between 30 and 50 minutes. This means there was a total of 25 children. The number of children that finished the puzzle in over 30 minutes was 4, so 4 out of 25 times 100 gives 16%. Question 6. To find the median using the frequency chart, we start by looking at the total frequency, which is 32. Half of this is 16, so we need to find the 16th patient. 2 plus 5 is 7, and 7 plus 7 is 14, so we need 2 patients out of the 60 to 80 class. There are 10 patients in this class, but as we only need 2 of them, we calculate 2 out of 10 of the class width. This is 4, so we need 4 minutes into this class width, giving 60 plus 4, which gives us 64 minutes as the median. Question 6. We need to start by calculating the frequencies using the formula. As we have 2 patients in the first class, then 5, then 7 patients, which is a total of 14 patients, we need 2 of the next class to make it up to 16. We split that class into 5 lots of 2. We can see that the first 2 brings us up to 64 minutes waiting time for an estimate for the median. Question 7. We must first calculate the frequencies from the histogram, and we get 10, 15, 20, 16 and 9. When added together and halved, we get 35. 10 plus 15 is 25, so we need 10 of the third class to make it up to 35. As the third class has a frequency of 20, we need half of it to get to 35. Splitting the class in half gives us 12.5 as the median. We know this is just an estimate because in the 10 to 15 class we don't know where those 20 cars fall. They could actually fall between 12.5 and 15, but we distribute them evenly. Question 8. To find the median, we halved the total frequency. Now to find the lower quartile, we find a quarter of the frequency. The frequencies are 7, 14, 10, 10, 9 and 6. When added together we get 56, and a quarter of 56 is 14. So we need half of the second class added to the first class. Half of the second class brings us to 1.5 goals as the lower quartile. Question 9. Using the equation, we can find the frequencies for each of the bars. They are 600, 2100, 1000, 200 and 300 calls. So as 2100 is the largest amount of calls, the interval in which there were most calls was 10 to 40 minutes. Adding all the frequencies together, we can calculate that there were 4,200 calls altogether. To calculate the mean of group data, the first step is to determine the midpoint of each interval or class. They are 5, 25, 50, 65 and 85. These midpoints must then be multiplied by the frequencies of the corresponding classes. They are 3,000, 52,500, 50,000, 13,000 and 25,500. We then add these all together and divide by the frequency total. This gives us a mean as 34.3 minutes to 1 decimal place. Question 10. We know that the total shaded area is equal to 450 cars. If I split them into 45 equal blocks, I can tell that one block is worth 10 cars. There are 9 blocks over 35 miles an hour, so 90 cars were exceeding the speed limit by at least 5 miles per hour. To calculate the mean of group data, the first step is to determine the midpoint of each interval or class. These are 12.5, 25, 32.5, 37.5 and 42.5. These midpoints must then be multiplied by the frequencies of the corresponding classes, giving us 375, 6,000, 2,925, 1,125 and 2,550. We add them together, getting 12,975, and then divide by the total frequency of 450, getting 28.8 miles per hour as an estimate for the mean. We have 450 cars, so we need to find the speed of the 225th car. We can see that the 225th car falls in the 20 to 30 class. The class width from 20 to 30 is 30 minus 20, so is 10. And the class width from 20 to the median is the median minus 20, so we'll call that m minus 20. Now, comparing the frequencies in this class, from 20 to 30 miles per hour, we have 240 cars. From 20 to the median, we have 225 minus 30, so we have 195 cars. Putting this into an equation, we have the class width over the frequency for the full class equals the class width over the frequency for the part of the class we're interested in. That is 10 over 240 equals m minus 20 over 195. Solving this, we get the median as 28.1 miles per hour. We need to decide whether this is positively skewed, negatively skewed, or symmetrical. As the mean is greater than the median, this is positively skewed. As there are no extreme values and skewness is involved, the estimate of the median is a better representation of the average speed of the traffic on the road. Well, that's the end of my Histograms quick quiz. I hope you enjoyed it. I hope you come back to Melissa Maths again soon, and please don't forget to hit that subscribe button. Bye!